Hi, and welcome to The Click. Today we're going to be covering variation problems, where they arise from, and how to solve them. Let's go. So, what is variation? We learned in the last lesson that a formula is a representation of relationships between variables. However, you may sometimes be expected to create new formulas when given the variables' relationship with each other. There are two types of relationships between variables. One is direct and the other is inverse. Let's start with direct first. So a direct relationship is where one quantity increases, the other quantity will also increase, and when one quantity decreases, the other quantity will decrease proportionally by that same amount. Let's take the number of apples you're buying and your spending. As the number of apples you buy increases, your spending will also increase. When the number of apples you buy decreases, your spending will also decrease. Let's say the number of apples can be quantified as A, and your spending can be quantified as S. When we say that there's a direct relationship between A and S, it can be written like this, with this little swirly symbol over here. This means that there is a relationship existing between these two variables. Now, another type of relationship between variables is inverse. This can be where, for example, as you are writing more, as the number of words you write is more, the time you have for other activities is less. So, if the amount of time you're writing for is, or the amount you're writing for is increasing, then the time you have left is decreasing, and this is the other way around as well. If we quantify the amount of writing as W and the amount of time is T, then the inverse relationship for these two variables can look like this, or they can look like this. Either way, one of the variables has to be in a reciprocal, or they have to be 1 by this other variable. There has to be a variable over here. So how do we solve a variation problem, or how do we identify the equation from the relationship? So when we're given a relationship between two or more variables, whether it's inverse or direct, try to write the representation of that before making it into a formula or an equation. So let's start with the examples below. A varies directly with B. So in this equation, we can immediately use this directly keyword here and say that A will be directly proportional to B. There's not going to be any reciprocal or 1 by anything here, since it's a direct relation. However, we don't know how it's direct. Right now, we don't have an equation for this because of this symbol here. Well, there is a way to make this into an equation. We need to make, right now, A and B are variables. However, we need to bring a constant into this equation. To do that, we need to say that A is equal to K into B, where K can be any constant. When we say constant, we just mean any number. And it can be any variable representing this constant. It could be another n, it could be t. It just needs to be a constant. It just can't be, and it can't be a or b since we're already using those two variables. But it has to be a constant ultimately. Now, similarly, when we say p varies inversely with q, then we immediately start with knowing that one of these variables has to be a reciprocal. This means P, let's take Q as the reciprocal. So we can say P, with this little squiggly symbol here, is a proportional to this reciprocal of Q. Now that we have that, we need to multiply this area with a constant. So we say P is equal to K by Q to be able to get an equation. Now this constant can be anything. It can be a number, or it can be like, we can represent it with anything else. However, right now we're just using K. And with that, we're done. Here are the sources.